Hello again, fam. This is Coach Knight. I'm going to do a few problems to help you figure out the translations of sine and cosine functions. Here is the here's the complicated equation, including the translations, as we've discussed in previous videos. A is your amplitude. That is how high or how low the wave, when you graph the sine or cosine, the wave goes up or down from the midline. Each function has a period, and the period is found by saying 2 pi divided by k. The period is one complete wavelength. There's also something called the phase shift. And the phase shift is basically how far the graph moves left and right. So I don't know why they call it the phase shift. It's known as the horizontal shift if you want to relate it back to some of your Algebra 1, Algebra 2 days. But the phase shift basically moves the wavelength left or right. It shifts it. It translates it left or it translates it right. So the phase shift, to find it, is negative c over your k. And again, I'm getting these letters from up here in the equation. There's A, there's K, there's C, and H. H is your vertical shift. It's along with the amplitude, the easiest one to find, I should say, not prettiest. It's not very pretty. But it's the easiest one to find because you can just look at it and tell. And your vertical shift is simply H. It could go up or it could go down. Phase shift goes left or right. Period is basically like shrinking or stretching your wavelength. And your amplitude is how high and how low it goes, how far up and how far down. So we're not going to graph any of these, but I am going to show you how to state these four things: amplitude, period, phase shift, and vertical shift. Just one by one, here we go. For number one, your amplitude. Like I said, it's the easiest one. It's 4. Your period, again, is 2 pi over k. Well, k for this problem happens to be 1 over 2 would be your k. So you just divide it by 1/2, and you flip that over, and you say 2 times 2 pi, you get 4 pi would be your period. Your phase shift will equal to negative c over k. So negative c, here is c right here. It's my pi, so negative pi divided by the k, which again was 1/2. And you flip that fraction over to divide it, and you get negative 2 pi is your phase shift. So that means it moved left 2 pi radians. And finally, your vertical shift is whatever this number all by itself is. So it's negative 6, and as you might have guessed, that means negative means it went down. So those are your four parts of your function. You have the amplitude, period, phase shift, vertical shift. I'll do one more example for you. Number 2, same type problem. Your amplitude is 10. Remember, the amplitude is a distance, so it's always positive, no matter if it's negative or not. Your period is 2 pi over k. K for this problem, there's an understood 1 in front of that theta, so it's 1/4. So divide by 1/4, and you flip that fraction and multiply. You'll do 4 times 2 pi would be 8 pi, would be your period. Your phase shift, again, negative c over k. However, in this problem, in the parentheses, you can see we're not adding or subtracting anything. So my c in this problem is 0. So it doesn't really matter what the k is. It is 1/4, but 0 divided by anything is just going to be 0, which means there's not a phase shift. It doesn't shift left or right at all. It just stays. And then finally, our last one, the vertical shift, it's -5. So basically that means the entire graph just shifts down 5. So if I were to graph one, I'm just going to graph one just to show you. 1 period worth, and I always break them down into fourths. So we're going to 8 pi, so that would be 2 pi, 4 pi, 6 pi, and 8 pi, and my amplitude is 10, but my vertical shift is down 5. So I'm gonna add a few graphs or rings down here to my y-axis. So well, just count by 5. So this is 5, let's say -5, -10, and -15. So my midline would actually start down here at -5 because that's where it's saying it's vertically shifted. So it's been vertically shifted. The whole thing's been translated down to that -5 line. And then now we're treating this kind of like it's the x-axis before. So if I do this, I have to realize how far am I going up. Okay, first off, it's cosine, and it's a negative. So if you remember cosine, you start at the maximum or the minimum, and since it's negative, that means we're going to start down here at the minimum, and we're going to go down 10 because my amplitude is 10. So -5 down from there, down 10 would be -15. So I'm going to start there. I would go up at 2 pi. That's going to be where I'm crossing the midline. I keep going up. At 4 pi, I'll be at my maximum, which would be up here at 5. 6 pi again, I'm going to be crossing the midline. And then at 8 pi, I'll be back down here at a minimum. And so my graph looks like that. So basically, it's been stretched because normally the period is just 2 pi, but this period was 8 pi, so we stretched it out longer. And it's going up 10 and down 10 from my vertical shift of -5. So the entire graph has been shifted down 5. All right, 2 more. And basically these are just the reverse of 1 and 2. These, they want you to write the equation when they give you the amplitude, period, phase shift, and vertical shift. So when you do this, basically you are just finding all the parts. So I'll just use sine as example. K theta plus C plus H. Basically you're finding A, K, C, and H and writing the equation. So over here, the amplitude is always the easiest. The vertical shift is also easy. So A and H, very, very simple. It's finding the K and C that you have a little work to do. So to get K, I know the period, which my period is 4. It's equal to 2 pi over K. And now we can find K. We're going to cross multiply. 4K will be 2 pi. Divide by 4. K is pi over 2. So there's my K. So now I got 3 out of the 4 letters I need to write the equation. The 4th letter I need is C. So C, to get it, you do the phase shift. If you remember, phase shift was, in this case, pi. And the phase shift is always -C over K. So I say pi equals -C over, what was my K? My K is pi over 2. We are actually using the K that we found in this problem. So to figure out what C is, I'm going to multiply both sides by -pi over 2. -pi over 2. these cancel. And over here, I get negative pi over 2 squared, excuse me. And I'm trying to make sure I didn't mess something up. Nope, we're good. So negative pi squared over 2 equals c. And that's ugly, but that's the answer. So now we have c, and we have h, a, and we have k. And the last part is just to write the equation. So y equals, amplitude is plus or minus 8, sine k is pi over 2 times theta minus pi squared over 2 plus 10, plus my vertical shift. And if you did cosine, it would be the same thing, just with cosine. Plus or minus 8 cosine pi over 2 theta minus pi squared over 2 plus 10. There you go. Very, very simple. All right, last one we're going to do here. Number 4, again, we know A is 2/3. We know H is negative 3. It's finding the B and the C that's our problem. So, period. 3 pi will be 2 pi over K. So, I'll cross multiply those. 3 pi times K equals 2 pi. Divide by 3 pi. K is 2/3. So K is 2/3. The phase shift in this problem is negative 6. So it will be equal to negative C over K. Negative 6 is negative C over K is 2/3. Again, we just found K. So I'm just plugging that in. If I multiply by negative 2/3 on both sides, I get C, these cancel, equals, that would be positive 12 over 3, which equals 4. So C is 4. And so now we have all the letters we need. Y equals plus or minus, amplitude was 2/3 times the sine of K is 2/3 as well, theta, plus 4 is my C, and then finally my H is minus 3. And then to do the cosine equation, you just do the same thing, but you write cosine. Like I said, most of the time you don't have to do both cosine and sine at the same time. The directions of your problem will just tell you which one to use. So hope this helps. Y'all have a good job, good night, or good morning, or whenever you're watching this, and let's try to stay above the line as usual.